Assalamualaikum everyone, hopes you all are going good, great and well. So welcome back to the YouTube channel of Hania. So I'm back in another lecture, another video. So I'm here after a very long time, but I'm gonna be active from today. So if you are new, so don't forget to like, share, subscribe my YouTube channel, and press the bell icon to get the notification of my each and every video and stay connected to me. So yeah, let's start our today's lecture without wasting any of our time. So today's lecture is gonna be regarding rational numbers, which is a topic of mathematics. So we're gonna go through this topic. So let's start. So first of all, let's revise numbers, because for dealing with rational numbers, it's very important for one to know about numbers. So there are different type of numbers. So first of all, we're having natural numbers. So all counting numbers are known as natural numbers. For example, 1, 2, 3. Like in my school, I was taught, like, it was like my teacher, my coordinator was used to say that, as you know, natural comes from the word nature, and nature is created by Allah, and Allah is one, so that means it starts from one. So this was the way we used to remember it, but it's very easy for one to know it, one to come across it. So yeah, so the numbers, they start from one, and then they so go on, are known as natural numbers, whole numbers. Now all counting numbers, including zero, are known as the whole numbers. Like, this is same as natural numbers, but in natural numbers we start from one, but in whole number, that means everything whole, that means that they start from zero. So this is the only difference between both of them. Then opposite of natural numbers, which are -1, -2, -3, because natural numbers are 1, 2, 3, so definitely opposite means adding minus sign, because natural numbers are positive sign, so here we're gonna add minus sign with them. So these are the opposite of natural numbers. Then integers are also numbers, a collection of whole numbers, and the opposite of natural numbers is known as integer. For example, -2, -1, 0, 1, 2. So basically it is whole number, like 0, 1, 2, 3, 4, and infinite, and opposite of natural number. Now you should know opposite of natural number is -1, -2, -3. So yeah, this is integer. So hope so now you know what is basically natural numbers, whole numbers, opposite of natural numbers, integers. So then fraction and its types. So fractions, there are three basic types of fractions. So one is proper fraction, improper fraction, and mixed number. So what is proper fraction, improper fraction, and then the mixed number? So proper fraction means when the numerator is smaller than the denominator. That means if we are having total parts in this region, the total parts are 6, and out of which 5 are okay. So definitely the total things are 6. So in the denominator we're going to have the total parts, which are 6, and in the numerator we're going to have the shaded parts or selected parts, which are 5, because 5 are colored blue. So that means 5 over 6. Now here, by looking at this and by looking at the figure, we can say that this is a proper fraction. Why? Because numerator is smaller than denominator, or denominator is greater than the numerator. Then we're having the improper fraction. Now what is in the case of improper fraction? Here numerator is equal to or greater than denominator. Now if in the case here we are having like in this case you can see that it is like 6. So here all the region is 6 selected, that means it's 6 over 6, that means 6 over 6, that means one whole. So it is an improper fraction, it is an improper fraction. And in the second place you can see that there, what we see is that it's 6 total parts, and out of which 8 are shared. That means it's 8 are 6, because here we are going to combine these two. So that means if total parts are 6, and out of which this whole 6 and 2 here 8 are shaded, that means 8 over 6, that means numerator is 8 and denominator is 6. Now it's also an improper fraction. And then after converting that, we are going to go into mixed fraction. Then the in improper fraction basically invents the mixed number. In proper fraction we're having no mixed number, but in improper fraction, because definitely the denominator is going to be smaller, so we're going to further convert it by using the division method, and then it's going to give us a mixed number. So it's going to be in a QRD form. So mixed number is e plus proper fraction. Okay, here you guys can see, like here we are having 6 here plus 2, 8, that means So we're gonna solve that 8 divided by 6. We're gonna properly solve that QRD form. 1 is gonna be quotient, 2 is gonna be remainder, and 6 is gonna be the dividend. So this is what you're gonna got. And now here you can also check it, like 6 multiplied by 1, 6 plus 2, 8. That means the answer is correct, because here we're gonna multiply and then add these two. So now that means this is actually true. Now place value chart of decimals. Now decimals place value chart, this is the place value chart of decimal. So first of all, it's very well known from you guys really know it, that ones, tens, hundreds, thousand, ten thousands, 1. Then we're gonna, like, exponent, we're gonna work upon the exponent, like if it's in one place, so 0, 10, because we know value of 10 we're gonna add it, but in ones it's gonna be 0, in tens it's gonna exponent or power is gonna be 1, and then in hundreds 10 is gonna be to raise the power of 2. That means you're gonna multiply that number with 10 two times. So this basically means it, that's very well known. And before the decimal point, the part is known as whole part, and the decimal point, this is the dot that is represents a decimal point, and after that it's all a decimal part. And there are two parts present inside it. You can say it fractional part as well. Okay, so you can say the whole part has fractional part as well. Okay, so like it's gonna be like tenth, hundreds, thousands, ten thousands. So it's like this, it's the same, like 1 hour 10, 100, 1,000, 1 hour 10,000. So that means now it's gonna be raised to the power minus. So it's gonna be like 10 is gonna be raised to power minus 1, 2 is gonna be like raised to power minus 2, 10 is gonna be like raised to power minus 3, and 10,000 is going to be like raised to power minus 4. Okay, so this is how we actually do solve it. So hope so it's clear to you. Then write the place values of 13546.789 and base 10. So when we're gonna do that, for doing that purpose, first of all we're gonna put the digits, and then we're gonna write their places. And then after writing the places, as you know, ones is gonna be raised to power 0. So after, according to raised power, as 1 is having no raise, in ones there is no raised to power, so it's gonna be 6 is gonna remain 6, and here tens is like 4, so it's gonna be like 10 raised to power 1, so it's gonna be 40, then hundreds and 500. So like that you're gonna do. Okay, so here you guys can see, like, it's supposed to multiply by 1 multiply by 2. Here's the whole working which is shown here, so you can click it. Okay, now types of decimals. You should know what are the different types of decimals. So decimals, do the decimal digit go forever? So there are two cases in it. What are the two cases over here? So the two cases over here are, like, in the case if it's no, in the case if it's yes, so do the decimal digits go forever? So no. For the no, the reasoning is terminating decimal, it has finite number of digits after decimal point, like 3.5, 3.9678. That means that it basically means that terminating decimal is basically a number that ends after a finite number of digits after the decimal point. Like, unlike non-terminating decimals which have a finite number of digits terminating, have a distant end. So that means finite digit, like if they have finite digit, means they have a set of number of digits after the decimal point, and it means that they, unlike recurring decimals, terminating decimals do not have a repeating pattern of digits. The pattern of digits do not repeat in the terminating decimals. So basically you can say there are decimals that have finite number of decimal places. Like there are decimal the decimal places are actually really finite in it. And then if it's yes, so why it's yes? It's yes because a non-terminating decimal has a infinite or uncountable number of digits after the decimal point. For example, like there is a 3 dot always represented because they are infinite. They are infinite, it means they are uncountable. So a non-terminating decimal is a decimal that has a finite or that has an infinite number of digits after a decimal point, and unlike terminating decimals after which a finite number bar of digits, non-terminating decimal continue infinitely. They can be further characterized into repeating and non-repeating decimals basically. Then when coming inside the the incoming inside the non-terminating decimals. Now if their question arises, is there a repeating pattern after decimal point? So there are again two cases, yes or no, and it only stands for the non-terminating decimals. Recurring decimals and non-recurring decimals. Recurring decimals, if a digit or a block of digit are repeating itself finite times, finite number of times after the decimal point, like after that we're gonna have further decimal point. And recurring or terminating decimals are number with a decimal representation that goes on forever without stopping, and where a specific sequence of digit repeats after knowing about the decimals. And then we are having like the again for the no one, we're having like if the no digit of or block of digit are repeating itself finite numbers of times that the decimal points. Again it's the same thing here, but here what are you having, that the numbers are not repeating of the numbers are not repeating, like non-terminating non-recurring numbers are decimals that continue infinitely without any repeating pattern. These are also known as irrational numbers. So like as a pi, the square root of 2, and Euler number, these are basically the examples of it. So yeah, let's answer these questions together. So is sum of any two integers always an integer? So for me it's a yes. Okay, it's a yes. Okay, for example, like minus 5 plus minus 6, it's gonna give you minus 11, which is an integer. Is a difference of two integers and an integer? So yes it is, because 9 9 minus 5, that means plus, minus plus, that means 9 plus 5, that is 14. It's integers. The product of two integers always an integer, so it's yes, because minus 3 plus 2 is equals to minus 6, which is an integer. It's constant of two numbers or two integers always an integer, so it may or may not be integer. Like minus 1 divided by minus 2 is equals to plus 2, so it depends on the situation. Like, but if it's gonna be minus 2 divided by minus 4, that is equals to plus 1 about 2, which is not an integer, but because not an integer, it is expressed as a fraction. It's known as a rational number. So what kind of number are these? So basically minus 1 over 2, minus 1 over minus 2, minus plus 1 over minus 2. Quotient of an integer and our known zero integer is known as rational number. So rational number can be expressed as a fraction. So the number which can be expressed like a over b, where a and b are integers and b can never be zero, that means gonna be an integer. Sorry, a rational number. So whenever you find a situation where a and b, where a and b are integers, so that means they are rational number until unless b is not zero. If b is zero, then they are not rational numbers. So in mathematics you can say that a rational number is a number that can be expressed as a quotient or fraction of two integers, a numerator p and a non-zero denominator q. For example, it's a rational number as a very integer. So like the rational number, like any fraction with non-zero denominator is a rational number. So for some of the examples of rational numbers are like 1 over 2, 1 over 5, 3 over 4, and so on. The number 0 is also a rational number, as we can represent in many forms such as 0 or 1, 0 or 2, 0 or 3. But if it's gonna be in if it's gonna be in the denominator, so definitely it's gonna be not a rational number. Okay, so then Venn diagram. So here you can see this Venn diagram. So according to this diagram, Venn diagram, it tells you about natural numbers, whole numbers, integers, rational numbers. Now natural numbers are like 1 to 3, whole number includes 0 and 1 to 3, so on. Integers include both of these as well as minus signs, like the opposite of natural numbers. And then the rational numbers, they include the square root and the fractions and the rational numbers, the integers and everything. So activity time. So here's the activity time. So check yourself. From the bowl of numbers, pick a number and write them under the rational or irrational box. Now minus 1, as you know, minus 1 comes in the box of rational number 0, 2, square root of 4, and then 3.125, 7, 12, and then this decimal fraction, which is 2.678812, 4 or 5 minus 2 or 3, 0.33, and so go on. So these are all rational numbers, and a pi and 5 or square root of 5, these are irrational numbers. So now we're here, what we need to do is we need to express the following rational as decimal. So as we're having 3 or 5 and we want to represent is as a we want to represent this as a rational number. So for that purpose, what we're going to do is we're going to place it first of all. So we are going to have 3.000, or if you're putting 3, that's even though correct. And then we're going to put 5 in the place of a divisor and 3 in the place of a dividend. Then what first of all we're going to do the zero step. So we are going to add 0 in the quotient place as well as down, as well as under the dividend, and then we're going to subtract it. We're going to get 30. Why? Because after this point we were having 0, so we're going to put the 0 back. It's very important for you to put point 0. It's okay if you don't put the rest, but it's very important for you to put point 0 with 3. So after putting the decimal place, you're gonna because we put the decimal place in the dividend, we're gonna also put in the quotient, so we're gonna get 30. So 30 is basically, so as you know, 30 is also present in the 30 is also divisible by 5. So we're gonna put 6 as it's 6 times. So then we're gonna solve it. So actually the answer we're getting is 0.6. So here the 0.6 is basically the rational as a decimal. So now we're gonna express the following rational to the numbers of decimal places given the bracket. So it's like 17 over 53. So like here we're having 2 decimal places, so we're gonna work with 2 decimal places. Then we're gonna put in the dividend place, we're gonna put 17.000 and so go on, and 15 in the divisor, 53 in the divisor place, and we're going to do the 0 step. After doing the 0 step, you're going to bring down 1 7, and then after the point we're going to put the point upwards as well with 0, and then we're going to bring down 1 0 back downwards, and then we're going to get 3. So like 53, 3 times 159, then we're going to subtract it, we're going to get 110. So then again it's going to be divisible with 2, so we're going to do that, and we're going to get 4. That means the actual answer we are going to get is still we're going to have the digit 4 left with us in the remainder, but we're going to work on it, but we're going to get the answer as 0.32. Then all the points to remember, that's very important for you guys to remember this point. Okay, so points to remember is all integers are rational numbers, 0 is also a rational number, all terminating decimals are rational numbers but they can be expressed as fractions, all non-terminating recurring decimals are rational numbers as they can be expressed as fractions, all non-terminating non-recurring decimals are irrational numbers because they can't be expressed as fractions, square root of an imperfect square will always be an irrational number. So points to ponder are like every rational number can be expressed as a terminating or repeating decimal number, which cannot be expressed as either repeating or terminating decimals are not rational numbers. I explained everything to you. In circle yes no for each of the following by giving a reason, like is 0.5 a rational number, so that definitely is, and is minus 0.5 are irrational numbers, so no, it is a rational number. Is 0.5555 a rational number, so yes it is, even though it is not terminating but still it's recurring. Is 3.14 a rational number, so yet it is is pi is equals to, like, as 22 over 7 is a rational, pi is a equation of pi, so it's a rational number, so yeah, it's not, no, it's not a rational number. So state whether each of the following statement is true. For every integer is a rational number, so yeah, it's true. Every rational number is a whole number, that's false. Every irrational number is a real number, true. Pi is a rational number, that's false always. Every real number is an irrational number, that's also false. Collection of all rational irrational numbers are called real numbers, so that's actually true. Ordering of rational numbers. Now put the following rational number in descending order. So the least multiple or denominators are 16, as you know. So each number needs to be converted so that all denominators are same. The numerators can be then compared. So that's why I'm going to multiply this one with 3, this with 6, and this is already in the form, so we're going to multiply it by 2. Then after converting them, we're going to get these equations, and then we're going to stare at whether which is greater, which is smaller, and it's very important for you to choose the greater than sign, and then this is the, and you're gonna convert them back to this situation, because then you're gonna lose your marks if you don't convert them like that. Okay, so then again we're having here ascending order. So the common denominator is 24. LCM of denominators is 24, so each number needs to be converted to their the denominators are the same, so the numerators then can be compared. So then here you're going to multiply this with 6, this with 4, this is 3, this with 2, and then you're going to get simple answers, and you're going to convert them back to the original place, and then you're going to use this less than sign. Okay, so now here this is actually what you can do if you want to do. You can arrange these ascending order. If you want to solve that, you can actually do that. And then what you need to do is like you can use this, it's a word problem, so you can use this for doing that in descending order and doing this in ascending order. So that's it for the class. Hope you like it. Bye bye, take care, and Allah Hafiz everyone.